Lecture 2, Popper and the Problem of Demarcation.
Having worked through some preliminaries last time, we turn now to the most direct of our big questions, namely, what makes a science a science? And as advertised last time, no sooner do we ask a big question than we start clarifying it into smaller, more manageable questions. So first I'd like to offer an explicit restatement of this question, and then further clarifications. The problem of demarcation is what we're going to call this challenge. It asks us to distinguish in a motivated and non-arbitrary way between genuine sciences and pseudosciences. Now we have to see what that statement amounts to. Not every non-science is a pseudoscience. There are other epistemically special enterprises out there. And while it's useful to distinguish mathematics or engineering or art from science, that's not our main problem. It's generally thought that it's either less likely or less dangerous that these undertakings should get mistaken for sciences. A pseudoscience, on the other hand, is a discipline which claims the special epistemic status that science holds, whatever exactly that status turns out to be, for the reasons that science gets that status, whatever exactly those reasons turn out to be. But a pseudoscience does not, in fact, merit such status. Astrology provides the classic example. If any of you are fans of astrology, I apologize, but I need some poster child for pseudoscience, and so I will be assuming that astrology can fairly be called a pseudoscience. Now, to call something a pseudoscience is not to deny that it might sometimes make true and important claims. Nevertheless, the idea is that such claims are not supported in the way that scientific claims are, and so the claims of the pseudoscience don't deserve quite the same status that scientific claims do. Likewise, to call something scientific is not to deny that it might well be false. We know that lots of well-supported scientific statements have turned out to be wrong. So a demarcation criterion is perhaps best thought of as a qualification for a special kind of competition, like the Olympics. I owe that metaphor to my colleague David Austin, by the way. Calling a theory scientific is not to endorse it as a winner, but only as a worthy competitor. It deserves to be in the field. Pseudoscientific theories, on this view, are not to be allowed into the competition. So this captures our sense that to call something scientific is normally to praise it in some way. And the central idea is that pseudosciences don't deserve the praise that the sciences do. It's not clear exactly what the payoff for making the field of this scientific competition is supposed to be, but at a minimum, it involves being taken seriously in certain ways. We think the deliverances of science deserve a kind of serious consideration. Now, this is one of those philosophical problems, perhaps they're too rare, that is of clear practical as well as theoretical importance. And attention to the practical issues helps us see what's at stake in calling something a scientific discipline. For instance, whether a given discipline counts as science would appear to determine what role, if any, it can legitimately play in school curricula. We'll examine this issue next time when we spend some time discussing the creationism controversy. Whether a given discipline counts as a science also says a lot about the amounts and kinds of funding it can or should receive. Congress directed the National Institutes of Health to establish an Office of Alternative Medicine. Some people thought this was a misuse of scientific resources, while some thought it was a paradigmatic example of scientific open-mindedness, and hence admirable. We'd like to be able to resolve such controversies. Some important practices turn on controversial claims about scientific status. It's been argued, for instance, that IQ testing is pseudoscientific, that an IQ test is not significantly correlated with anything except the ability to take IQ tests, in which case perhaps that practice should not have the role in our society that it has. So ideally, we'd like to settle these claims by appealing to a clear definition of science. I emphasized in the first lecture that I don't think definitions are always the right place to begin doing philosophy. Nevertheless, there are good reasons to pursue them, if not always to start out from them. But let me, as it were, define definition. By a definition, I mean individually necessary and jointly sufficient conditions. I'll explain what that amounts to in a moment. The legal definition of an object often exemplifies these criteria. So the legal definition of, say, bourbon whiskey says that the grain used must contain between 51 and 79% corn, and that the whiskey must be aged for at least 2 years in new charred oak barrels. Not that you need to know that much about bourbon. The point is, if these were all the criteria, they're actually not, but let's pretend that they are, then each is a necessary condition for something counting as bourbon, and together they are sufficient for something counting as bourbon. That's a philosopher's definition. It's not a lexicographer's definition. Lexicographers go out and find what people mean by terms. Philosophers are not empirical scientists. We're interested in clarifying the meaning of the term. People might not mean exactly that by bourbon. Yet, the idea is that definition reveals what it is to be bourbon in a way that the lexicographer's notion might not. Now, the nice thing about a definition like this is it displays the criteria that we're using. So if we have such a definition, it would show us on what basis we're distinguishing science from pseudoscience. Mere agreement about the cases, this counts as science, this counts as pseudoscience, even if almost all of us agree and agree confidently, won't tell us what our criteria are, much less how good they are. So a definition would be lovely, but good definitions are hard to come by. And we don't always need a definition in order to draw a confident distinction. The most famous statement along these lines is probably from former Supreme Court Justice Potter Stewart about pornography. I can't define it, but I know it when I see it. That might be adequate for some purposes, but those purposes are pretty limited. We've discovered about pornography even that it's a more complex notion than people might have realized, because, say, feminists and conservative Christians might agree on the cases, but really for quite different reasons, and they might disagree about unexamined cases. Likewise, we find pretty significant disagreement about whether something is a science or a pseudoscience. The Parapsychological Association was admitted into the American Association for the Advancement of Science in 1969. Now, does this reflect a scientific or philosophical judgment that the study of ESP is scientific, not pseudoscientific? Perhaps, but one would like to know the criteria according to which that group was admitted into the scientific society. So for all of these reasons, to help us settle difficult cases, to help us articulate and defend our criteria, a philosophical definition would be a lovely thing to have. Notice, however, that we can actually make a lot of progress without getting all the way to a philosophical definition. This accords with some of the things I was saying last time. If I have necessary conditions, I can confidently rule certain things out from counting as bourbon or as science. I can say, here are the necessary conditions. This thing doesn't meet a necessary condition, hence it's not science. Similarly, if I have sufficient conditions, I can definitively rule certain things in. I can say, here's a list of complete conditions, this meets it, so it must count. Notice, by the way, that the feeling one has that sufficient conditions are somehow harder to attain than necessary conditions isn't always right. You can know a sufficient condition without knowing necessary conditions. It's sufficient for being a U.S. citizen that one be born in the United States. One can know that without knowing necessary conditions for U.S. citizenship. So, with that background about what we'd like to have and what we're perhaps prepared to settle for, let's turn to Karl Popper's enormously influential solution to this problem of demarcation. Now, Popper is probably the philosopher of science most influential among scientists. There might be a bit of a psychological explanation here. Popper's account of what makes science special treats scientists almost as heroic. But he didn't impress scientists just by flattering them. His solution to the demarcation problem, which is central to Popper's whole philosophy of science, is elegant and provocative, and there seems to be something profoundly right about it, though as we will see, it comes with a slew of problems. Popper came of age in Vienna after the end of World War I. This was an enormously rich culture, musically, artistically, philosophically, and in terms of alleged and actual sciences. Lots of intellectual ferment on the science side of things and on the art side of things. Popper was especially interested in Einstein's theory of relativity, Karl Marx's theory of history, and the psychological theories of Sigmund Freud and Alfred Adler, about which more later. The new work in the theories of history and psychology was explicitly put forward at least by some of its major proponents, as scientific. Friedrich Engels, for instance, held that Marx was extending Darwin's work, so that Marx was scientific in the way that Darwin was, extending that work into the realm of society. And Freud similarly compared himself to Darwin and suggested that science is being carried over from the notion of the biological to the notion of the social or psychological. Popper himself worked with Alfred Adler, and what's distinctive about Adler's approach to psychology is that he made the self's struggle to deal with feelings of inferiority central to the explanation and treatment of behavior. Now, perhaps because these were relatively new, and one might have thought promising theories, Marxism probably looked more promising before the Russian Revolution, or before the outcome of the Russian Revolution was widely known. Perhaps because everything gets taken especially seriously in Vienna, but it's worth noting that the claims of these disciplines to count as scientific were taken very seriously at this time in this place. These days, perhaps not so many people think of Marx or Freud as potential scientists, but Popper and his friends did, and so that's worth appreciating as we try to see the problem with which Popper was wrestling. Now, Popper became convinced that Einstein's theory was to be distinguished from those of Marx, Freud, and Adler by its openness to criticism. We're going to focus a lot on this. This is crucial for Popper. It provides the key to his solution to the problem of demarcation. But first I want to explain that this openness to criticism was central to Popper's philosophical work more generally than just in the philosophy of science. Popper left Europe when the Nazis came to power, and he did important work in political philosophy that builds on his work in the philosophy of science. In politics, as in science, Popper stressed the importance of openness to criticism. His most important work in this field is called The Open Society and Its Enemies, published in 1945. That fact is pretty noteworthy, of course, right after the end of World War II. An open society is characterized for Popper not just by the freedom of individuals to voice criticisms of government policies, but by the effectiveness of such criticism. A society is open if those in power welcome criticism and respond to it, though of course they're not obligated to respond exactly as the critics would like. But this notion of openness to criticism is central not just to Popper's work in the philosophy of science, but to his work in political philosophy. The very same thing that makes something a good scientific theory makes a society a good society. It is perhaps ironic, then, that Popper himself did not take criticism well at all. There is perhaps a lesson here for all of us. One can devote one's life to an ideal without necessarily being able to live one's life in terms of that ideal. Popper's emphasis on criticism stems from a rejection of what we might think of as the most straightforward criterion of demarcation. That idea couldn't be simpler, is that what makes something science is the way in which it's supported by empirical data. Why won't this work? Popper realizes that pseudosciences are chock full of appeals to observational evidence. Astrology is full of biographical and astronomical data. Freud and Adler have dozens of case studies. There's lots of observational evidence that a pseudoscience can claim supports its theories. So as Popper sees matters, observation is cheap. He characterizes observation as interpretation in the light of theory. Now, as we'll see later in this course, a number of philosophers try to emphasize that observation can be independent of theory, that it can be fact as opposed to theory. We'll worry about that later. Popper, in order to respond to this challenge of demarcation, wants to think that the notion of observation is pretty theory dependent. He doesn't want to deny that the astrologers have observational evidence for their views, or that Freud or Adler have observational evidence for their views. This is a relatively permissive conception of observational evidence, but it's a reasonably motivated one. Now, the Marxist true believer, Popper had flirted with Marxism early in life and perhaps had the bitterness of the lapsed Marxist, could find confirming evidence everywhere. In the events reported in the paper, which show class struggle, in the ways in which the events are reported, which show the class bias of the paper, and of course in which events don't make it into the paper, because those, even more than the events that are reported, show the class bias of the paper. And apparent counter-evidence can be turned aside and sometimes even turned into confirming evidence by a clever pseudoscientist. Now, Popper is not questioning the sincerity of pseudoscientists. He's not saying they're pulling a fast one. He's saying the standards of evidential support are loose enough so that it's not clear when we've got evidential support worth having. Let me explain more clearly what I mean. A Marxist could explain the failure of Marx's prediction that the proletarian revolution would begin in a highly industrialized society, like England or Germany, by saying that Marx hadn't taken into account the charisma and skill of an organizer like Lenin. And that's why the proletarian revolution happened in Russia rather than in, say, Germany or England. Similarly, Popper became disenchanted with Alfred Adler when he realized that Adler would offer the very same explanation for horrible and wonderful actions. If someone, say, killed a child, Adler would say that he was doing it to show that he dared do so, that he was trying to overcome feelings of inferiority, and that's why he killed the child. Likewise, if someone saved a child from drowning, it was for the purpose of overcoming feelings of inferiority. Evidence is too easy to come by for a pseudoscience. No evidence falsifies a pseudoscience, and almost everything can be seen as confirming it. Now, this is an important insight, because Popper came to see what are standardly considered the two major virtues of scientific theories, being able to explain lots of data and being confirmed by lots of observational evidence. He came to see these as closer to vices than virtues. Now, a point about preliminaries, echoing something we said last time. We will get fancier about confirmation and explanation later. For now, it's perfectly fine to understand these terms rather loosely. The point is that Popper is unimpressed with a theory's ability to fit the data, even with the ability to fit quite a lot of data. Why? Because astrology fits quite a lot of data. We'll worry a little bit more about that later. A good theory for Popper isn't one that fits the data well, it's one that is informative, that makes surprising predictions, that rules out a lot of what we would otherwise have thought possible. So a good theory, in some sense, should be as improbable as possible, so that it is readily falsifiable by observation. This is a striking claim about what's essential to science. Einstein's theory of relativity came to exemplify genuine science for Popper. He's motivated by the contrast between what he sees Einstein doing and what he sees Adler and Freud and Marx as doing. Einstein's general theory of relativity leads to the surprising prediction that light would be bent by the gravitational field of the sun. This was not an observation anybody had ever made. You need a total eclipse in order to run the experiment. But it's a consequence of Einstein's theory. So when Arthur Eddington organized some expeditions at the next total solar eclipse, and verified that light was bent by approximately the amount that Einstein had predicted, it was a great triumph. It convinced many people that Einstein was right. That's not the point for Popper. Even in a case like this, Popper is not that convinced that the fit between theory and evidence is crucial. What impresses Popper is that the theory was bold. It made a prediction that could readily have been falsified. And in that case, having your prediction accord with observation counts for something. So the moral for Popper is that a scientific theory should make what he calls bold conjectures, rather than merely accounting for observations that are already in. That's too easy. Riskiness for Popper is the key to genuine scientific status. So relativity scores points for telling us which observations would be incompatible with the theory. Pseudosciences are confirmed by almost everything and falsified by almost nothing. Genuine sciences, on the other hand, court refutation. So the mark of a genuinely scientific theory, Popper calls falsifiability. Now, as usual, we take a deceptively simple and elegant formulation, and we worry it into a number of formulations, each of which is less elegant, but hopefully each of which is a bit clearer. Popper sometimes writes as if falsifiability, and hence scientific status, comes in degrees. Marxism, as Popper emphasizes, really began as a predictive science of history. But the theory was modified to protect it from apparently falsifying data, like when the revolution happened in Russia rather than, say, Germany. And at that point, its scientific status at least decreases. Popper sometimes writes as if it disappears, sometimes as if it decreases. Note that this is already a bit of a problem for the Demarcation project as standardly conceived, because the Demarcation project as standardly conceived treats pseudosciences as different kinds of things from sciences. It's not a lesser science, it's a non-science. So if, on Popper's view, the difference between a science and a pseudoscience is one of degree, that modifies our problem of demarcation in ways that we're going to have to keep track of. Another clarifying observation: Popper's theory is both descriptive and normative. He claims both that this is what scientists, at least for the most part, do, and that it's what they should do. Now, it's worth noting, since some of these claims, for instance, that scientists don't seek confirming evidence for their theories, that claim doesn't seem obviously true. So Popper's theory is not an empirical claim. It's not grounded in observations of what scientists are doing in their labs. It's a claim about what a scientist is doing insofar as that person is doing science. A given scientist might think he or she is getting observational evidence, but that's a misunderstanding of what he or she is doing, according to Popper. The essentially scientific part of what's being done is developing theories that can be falsified and trying to falsify them. One more clarification: though he's sometimes read this way, Popper is not really offering a definition of scientific status. He's really only offering a necessary condition. He's not saying that all falsifiable statements are scientific, but only that all scientific statements are falsifiable. Why? Well, falsifiability is a pretty weak condition. The statement, "I will be struck down by Elvis as soon as I finish this sentence," all right, I'm safe, is falsifiable. Why? Because we know it's false. But it doesn't follow that I was just now doing science. I said something falsifiable, but that doesn't suffice to make it scientific. Now, of course, this leaves unanswered questions about what else it takes for a theory to be scientific. But perhaps we've made some progress, and we'll settle for progress at this point. To call something unscientific is not necessarily to call it worthless, or even scientifically worthless. Popper thought that Freud, Adler, and Marx were onto some true and important things. And an untestable metaphysical framework. Metaphysical is another one of those philosophers' words. It comes from Aristotle. Meta is just the Greek for after. It's the book that came after the physics. It has come to mean something like beyond. Metaphysics concerns the basic stuff of the universe, whatever that is. So a metaphysical claim is one that tries to describe the way the world is, but isn't scientific. And Popper grants that there can be some scientific value to untestable metaphysical statements. Atomism, for instance, the hypothesis that objects are composed of little bits of matter, little particles, was not a testable hypothesis for much of its existence. It was a metaphysical picture, but one that indirectly encouraged genuine scientific research. So Popper wants to say, while it wasn't testable, it wasn't scientific. But that doesn't mean it wasn't a valuable contributor to science. It just wasn't itself a scientific theory. As we will see, Popper's contemporaries, the logical positivists, tended to take a much dimmer view of metaphysics. They see it as dangerous nonsense. Now, Popper even thought that Darwin's principle of natural selection was scientifically valuable, but ultimately unscientific. Why is that? Popper worried that there's no testable predictive content to an idea like that fitter individuals will tend to survive and reproduce. His worry, at least for much of his career, was that fitness is virtually defined in terms of survival. Which organisms are the fit ones, the ones that survive and reproduce? That's not sufficiently enlightening. It's a circular definition. Now, this criticism of Darwin, though not the claim that Darwin provides a useful metaphysical framework, has been taken up with much vigor by creationists of various stripes. Popper, in the 70s, changed his mind about this, fittingly when giving the first Darwin lecture at Cambridge University in England. He instead argued that the Darwinian claim about survival of the fittest is not an unfalsifiable definition of fitness, but instead a historical hypothesis, or a set of historical hypotheses, about the causes of traits in current populations. So, on this revised understanding of Darwin, this will show us the difference between science and pseudoscience. It says that some traits have their prevalence caused by selective forces rather than, say, something like genetic drift. What's genetic drift? Well, in creatures which reproduce sexually and which have modest numbers of offspring, not all of the parents' genes are going to get passed along. Right? Only some of your genes get passed along to your children. That's not due to selective forces, that's randomness. These genes are not tested in nature, they never got passed along in the first place. So some traits fail to make it into the next generation, not due to any fitness pressures, but due to random factors, all of which get summarized under the heading of genetic drift. Genetic drift tends to average out in large populations, but not necessarily in small ones. And this is an aspect of evolution of which Darwin seems to have been unaware. But the point is, Popper thinks you can turn the Darwinian hypothesis into a falsifiable one with a perhaps more sophisticated understanding of these notions. So it says of certain traits that the historical cause of them can, via statistical modeling and things like that, be shown to be selective pressures rather than, say, genetic drift. Now, getting clearer about falsifiability, as we just have, brings us to some criticisms that Popper's view faces. A statement like, there is at least one gold sphere, at least 1 mile in diameter somewhere in the universe, doesn't seem to be falsifiable, at least not on the basis of any finite number of observations. You can look everywhere you want, there's still a whole lot of universe out there, and you can't show that statement to be false. So is that an unscientific statement? Well, it doesn't seem unscientific. Popper responds by claiming that statements that have that kind of logical form, there's something out there somewhere, are not important for scientific purposes. We don't need to get bogged down in that sort of case. What science cares about are law-like statements, and those are readily falsifiable. Those have the form of something like all copper conducts electricity, and that can be falsified by one sample of non-conductive copper. A more serious problem for Popper, along these same lines, concerns probability statements. A run of 56s in a row does not automatically falsify the claim that this die is fair rather than loaded. You'll get some unlikely events sometimes. But probability statements are awfully important for science. This was implicit in our discussion of genetic drift. So how do we make the statement that it's very improbable that this gene would have stuck around through genetic drift? How do we make that meaningful if no particular run of experience can falsify it? Popper thinks that scientists can agree about how improbable something needs to be before we count it as falsified. It's not clear how satisfactory this answer should be, because we'd like to know what the basis for this agreement is. Mere scientific consensus doesn't seem as satisfactory a resolution as we would like. Popper also does not adequately distinguish the question of whether a theory is scientific from the question of whether it is handled scientifically. Are theories scientific in themselves, or is this a function of how a theory gets treated? You might think that the same theory could be handled scientifically by some practitioners. Some Marxists might drop their theory when it has false predictions, and unscientifically by others. Popper often writes as if falsifiability is, as it were, a logical property of statements, and that scientificness is then a property of a theory itself rather than what gets done with the theory. This issue will loom large in our next discussion. Arguably the most important objection to Popper is that good scientific theories are not cheap. It's not clear that scientists do or should, that's the descriptive normative issue, reject theories whenever they conflict with observed results. From reading Popper, you might get the feeling that scientists would have been anxious to reject Newtonian physics when Uranus did not have the orbit that Newtonian physics predicted. Instead, they kept Newtonian physics and posited an as-yet unobserved planet that turned out to be Neptune. Well, Popper has to explain how that's different from and better than the Marxists saying, aha, you didn't take Lenin into account when predicting where the revolution was going to happen. Now, not all such moves are created equal. One might think that there's an independent possibility of testing the Newtonian hypothesis that there's another planet out there, and no such way of testing the Marxist hypothesis. But even such moves as this might not give Popper the distinction in kind that he sometimes seems to want between doing science and doing something else. Furthermore, if physicists hadn't found Neptune pretty much right where the theory predicted it should be, do you think then they should have dropped Newtonian physics? A number of scientists are quite influenced by Popper, and they seem to think of themselves as ready to drop their best theories the moment the evidence turns slightly against them. But Newtonian physics is a good theory, and it would have cost an awful lot to just drop it as soon as it faces significant unresolved problems. Now, with a non-probability statement, we can say exactly what it means for the theory to conflict with observation. But even so, scientists don't always resolve this conflict by dropping the theory. Sometimes they modify the theory. Should we accept this idea that being highly confirmed and having wide explanatory scope aren't really virtues of a scientific theory? I mean, going back to Newton, wasn't it a great feature of Newton's physics that it could explain the orbits of the planets, the trajectory of cannonballs, the tides? Popper can try to make some room for this idea that fitting with a lot of data is in fact a virtue. As we'll see in Lecture 10, he actually doesn't want to. So we leave with the idea that it's not exactly clear how Popper's view should be expressed. Is it about the logical form of scientific statements? Is it about the way they're treated by their advocates? But however the view is formulated, it's not at all clear that it provides a necessary condition for scientific status. It does seem to play some important role in distinguishing genuine sciences from pseudosciences, but it's not at all clear that scientists do or should aspire to Popper's ideal. And we will get deeper into this problem next time. Thank you.